Hi everyone, and welcome to this video of G²CPU, where we're going to have a look at an exciting upcoming feature in version 1.3, which is multiple device support. Now, up to version 1.2, it was possible to communicate with different devices like the CPU, OpenCL devices like your internal GPU in your CPU, or even dedicated graphics cards like CUDA cards from NVIDIA or AMD and Intel cards. But with version 1.3, you will be able to actually communicate with all those devices at the same time. So you can have one algorithm running on the CPU with over 10, 20, 30 threads running at the same time to finish your algorithm or to calculate what you need, while the internal GPU is maybe doing some minor processing, while a dedicated graphics card is doing some of the heavy lifting. It will even be possible to have multiple dedicated graphics cards doing calculations at the same time. Now, for this example, we're going to have a look at an existing example which was shipped with version 1.2 with the first phase of machine vision. And that is contrast correction with histogram equalization. So we're going to use that and we're going to run that on multiple devices at the same time. So contrast correction, so this example is copied over from the example shipped. There's some minor adjustments just for this example to make it a bit better readable. So what we're doing here, first of all, we're setting the backend. So this is in this while loop. On the first iteration, we're setting the backend. The only reason we're doing that instead of just constantly doing that is just it takes quite a lot of time, like 1 or 2 seconds, depending on technology and what's loaded in. As not to slow everything down too much. Just set it once, only when you need it. And yeah, we're loading in an image file, we're transposing it so the image is tilted 90 degrees. We're just quickly visualizing the original image. And here we have our histogram that we calculate. So seeing, okay, what's the distribution of our grayscale values? Based on that, we correct our contrast with histogram equalization. And then we visualize it in this contrast corrected image. Now, the benefit of this two-step approach of contrast correction is that we can actually decide, okay, let's alter this histogram. Maybe create a histogram based on multiple images and do a generalized contrast correction so you have specific features still there. Or maybe alter your histogram so certain values are ignored while others are reused and so on. Now, if we run this example, this is based on an image in ArrayFire or provided with the examples of ArrayFire. It's a washed out image or drawing. And then when we run it through contrast corrections, our lines become more prominent. Now, the benefits of this is mainly in, for example, feature detection. Our edges become stronger, so we already know where to look. Certain features become stronger, so circle detection and so on will become much more accurate or higher hit rates. Now, to enable multi-device support, we just go to Properties, and a new symbol in conditional disable symbols of our project properties needs to be added, which is G2CPU _multi_device. And we set this to true. What this is going to tell the underlying compiler, yeah, we want to use multiple devices. If this is disabled, you can actually have multiple while loops at the same time, and they will all run on the same hardware. This is if you want to have multiple devices saying, hey, one while loop does this, the other one does that, you have to set this to true. Now, what's going to happen is every time a new thread is started in Windows, ArrayFire is going to assign a device to that thread. In LabVIEW, thread control is a little bit finicky, so if we put multiple while loops on screen, more threads are generated. However, LabVIEW scheduler has a tendency to swap around what thread, what code is running on. To enforce that the code is always running on the same thread, all we have to do is replace this with a timed loop, which will then enforce our code running in one or in a specific thread. I'm just putting the delta t to 0, saying, hey, please run at maximum speed, so it will act the same as a normal while loop. We don't have to assign a processor. You can do that if you want, but yeah, it's absolutely no requirement. Now, to say, hey, we want this code to run both on the CPU and on a dedicated graphics card, we just select the entire thing, we just copy it over as a copy, so you can just Control drag, give LabVIEW a few seconds, and that's it. So now this code will run with this specific backend, and this code will run with this specific backend. So what we can do is we can just quickly clean up this front panel, and we can then say here, hey, let's run the top one, which was the normal backend on CPU, and let's run this backend on CUDA. So that's it. That's all we have to do. We can select run. So our code is running, the algorithms are exactly the same, so the output will be exactly the same. But if we look at the outputs here, we can see the top one here is on the CPU, while the bottom one is on CUDA. Now this works on CPU CUDA, but it will also work on OpenCL. So for as many devices as you have, you can add more while loops as you go forwards, or more time loops as you go forwards. Or you can even decide having multiple time loops accessing the same backend, accessing the same device, have queues in them, and so on. You can go as complex as you want without any issue. Also, one quick thing, of course, this also propagates to SubVI, so you can have multiple layers of SubVIs, making your code simpler or visually simpler, but it's still assigned to that specific thread. So that's how easy multi-device support will be in version 1.3. Just put a timed loop around it and make as many copies as you want, and you can choose them independently. So I hope you find this interesting. I also hope you find this contrast correction interesting. There are a ton more image processing features and machine vision features already available for you to download today on VIPM. So if you want to see more, please let me know. If you don't like this format, please also let me know. If you have any special requests, again, let me know. And I hope to see you next week. Cheers, everyone. Bye.